You see, Tamarta jo online offline class start habo at that time. Uh, I think all of you got the message from on
Yes,
which
sir.
date you yes, yes. So on the first day, I shall check the copy of everybody. Okay. ତମର ଯୋଉ ଡେଟ୍ରେ ଆସିବ ସେଇ ଡେଟ୍ର ଫାଷ୍ଟ ପିରିୟଡରେ ଯଦି ସେଇଦିନ ଫିଜିକ୍ସ ଥିବ ସେଇ କ୍ଲାସରେ ମୁଁ ତମର ସମସ୍ତଙ୍କର ଗୋଟେ ପିରିୟଡ ହଉ ଦିଟା ପିରିୟଡ ହଉ ସମସ୍ତଙ୍କର କପି ପୁରା ଚେକ୍ କରାହବ ହେଲା ତମ you give the message to all. Okay, so we are discussing the coupled oscillation. Coupled oscillation, we have taken one example, coupled system of the two pendulums. Okay, so pendulum A and pendulum B, both are identical mass. Pendulum A moves a distance of x and the pendulum B moves a distance of y. Okay, so since we have taken two simple pendulums, uh, we have to establish two equations. Okay, each equation consists of two variables x and y. Why two variables? As already I told you in my definition, but coupled oscillation is nothing. Uh, one one body will influence the oscillation to other. Okay, the resultant oscillation is called as coupled oscillation. Okay, so we have to establish two equations and each equation consists of two variables x and y. So first, already we established the differential equation for pendulum A. So for pendulum A, your equation is d square x by dt square plus k by m into x minus y plus omega 1 square x is equal to 0. Okay. So you see the equation 1. Equation 1 consists of two variables x and y. Okay. Similarly, we have to establish for okay. So for pendulum B, again we have to find what is the net force is equal to restoring force plus gravitational force. Okay. So the chat box, I shall check. Those who have done, I told you, you have to do similarly for pendulum B. Those who have done the derivation, you mention on the chat box. Okay. So, again, for pendulum B, the restoring force plus gravitational force. Restoring force is equal to minus k into y minus x, and gravitational force is equal to minus mg into y by l. So after rearranging, you can find the final expression is d square y by dt square plus k by m into y minus x plus omega 1 square y is equal to 0. So this is the you can write. Those who have not done, I have written the final expression. Okay, so you have to write. Understood? अरे बुझिला ना नाଇଁ କିଛି ଗୋଟେ
Yes, sir.
ରେସ୍ପଣ୍ଡ କର ନହେଲେ କ୍ଲାସ ରୁ ଲିଭ୍ ହେଇକି ପଳାଅ ଯାଅ
Yes, sir.
ହେଲା କି ଦରକାର ନାହିଁ ତ ତମ ଭଳିଆ ପିଲାଙ୍କୁ ପାଠ ପଢେଇବା ଯଦି ଇଣ୍ଟରେଷ୍ଟ ନାହିଁ ଲିଭ୍ ହେଇଯାଅ କିଛି ନାହିଁ ଯୋଉ ଯେତିକି ପିଲା ଏମିତି ତ କମ ପିଲା ରହୁଛ ହଁ ପିଲା କ୍ଲାସ ଜଏନ ନ କରିକି ମେସେଜ କରୁଛନ୍ତି ମୁଁ ପ୍ରେଜେଣ୍ଟ ଥିଲି ହଁ ଯାହାର ଇଣ୍ଟରେଷ୍ଟ ନାହିଁ ଲିଭ୍ ହେଇକି ପଳାଅ ଯାଅ ଯାଅ ଅଲଗା କାମରେ ବିଜି ରୁହ ଓକେ ଗୋଟେ 50 ଥର କଣ ତମକୁ କହିବେ ମୁଁ ଏତେ ଛୋଟ ପିଲାଙ୍କ ଭଳିଆ ହଉଛ so this is d square y by dt square plus k by m into y minus x plus omega 1 square y is equal to 0. So this is equation number 2. Okay. So again the equation 2 consists of two variables x and y. Okay. Now uh, our next task is we have to convert the two variables into a single variable. Okay. So how? Next step you can write adding equation 1 and equation 2. That means if you add equation 1 and equation 2, what will your result? Adding equation 1 and equation 2. adding equation 1 and equation 2. What will be your answer? Who can say? If you add equation 1 with equation 2, what will be your answer? Are you writing or not?
Yes, sir.
Yes, sir.
Adding equation 1, you do by yourself. Equation 1 is there, equation 2 is also there. You add equation 1 with equation 2. What will be your result? The first term is equal to d square x by dt square, and the first term of
Plus d square
equation
y
2
by
is
dt square.
D square y by dt
s.
square.
So first term with the first term plus, if you take common k by m, what is your answer? If you take k by m common, this will be x minus y
X minus y plus
plus
y.
y minus x minus y plus y minus x. Then if you take common omega 1 square, this will be x plus y is equal to 0. So here plus x minus y plus y cancel, and since it is d square x by dt square, this is d square y by dt square, we can write d square by dt square into x plus y. This is the property of the derivative. Okay. So that means d square by dt square into x plus y plus. So the second term vanishes. The third term becomes omega 1 square into x plus y is equal to 0. So this is your equation number 3. Okay.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So adding equation 1 with equation 2, we got equation number 3. Now next step, write subtracting equation 2 from equation 1. Subtracting equation 2 from equation 1. Tell me, if you take the subtraction, that means equation 1 minus
d square by
dt square into x minus y plus. So directly I want to write, look here, that is k by m x minus y. This is k by m y minus x. We are doing subtraction, x minus y plus x. That means 2x minus 2y. So taking common, 2k by m common, the rest term will be x minus y plus omega 1 square into x minus y is equal to 0. Okay.
Yes, sir.
Yes, sir.
Okay. Yes, sir. So next step, this implies, right, d square by dt square into x minus y. So here is x minus y, here is x minus y. Again x minus y taking common. This will be omega 1 square plus 2k by m is equal to 0. Okay. So
Yes, sir.
look here, omega 1 square we have taken g by l. 2 is constant, k is constant, m is constant. So this the 2k by m gives you a constant. So if you add two constant, let that new constant is equal to omega 2 square, right? D square by dt square into x minus y plus, this is omega 2 square, not omega 3. It is gara madali. Okay, lekhichara nai, plus omega 2
Yes, sir.
square into x minus y is equal to 0, where omega 2 square is equal to omega 1 square plus 2k by m. Okay. Okay.
Yes, sir. Yes, sir.
Yes, sir.
So now equation 3 and equation 4 consist of again the two variables x and y. Our objective is we have to convert into a single variable. Okay. So now you can write, let us put q1 is equal to x plus y. Let us introduce, or you can write, let us put q1 is equal to x plus y and q2 is equal to x minus y. Let us put q1 is equal to x plus y in equation number 3 and q2 is equal to x minus y in equation 4. So what will be your equation 3 now? What will be your equation 3 now?
D square.
D square
d
by
square by
dt
dt
square
square into
of
x
q1.
plus y plus omega 1 square into x plus y is equal to 0.
अरे मु कहली से x प्लस y जगह हमें पुट करबा q1
d
d square
square
by
q1 by dt
q1
square plus omega square q1 equal to 0.
ओमेगा स्क्वायर नहीं आइछ ना ओमेगा 1 स्क्वायर नहीं आइछ
omega 1 square sir.
Omega 1
तमे
square.
तमर जदि तमे एते अन्य मनस्क होछ काई पाठ पढछ ताले हैं एटी कोन लिखा आइछ ओमेगा हमें तो स्टार्टिंग रो निया आइछ ओमेगा 1 निया आइछ ओमेगा 1 निया आइछ ओमेगा 2 निया आइछ सो एटे कोन एते डिफिकल्ट अछि लेट अस इंट्रोड्यूस q1 is equal to x plus y. So here instead of x plus y we have to put q1 एठी पुट करबा q1 q2 पुट करबा x minus y एठी पुट करबा x minus y जगह q2 है ना so equation 3 becomes d square q1 by d square plus omega 1 square q1 is equal to 0. So this is equation number 5. So this equation 5 is known as differential equation. This is the differential equation for pendulum A. And equation 4 becomes d square q2 by dt square plus omega 2 square q2 is equal to 0. So this is your differential equation for pendulum B. Okay?
Yes sir.
So now you see by introducing the new coordinate q1 and q2 we got equation 5 and equation 6. So now equation 5 in equation 5 how many variables are there?
1.
1. Again in equation 6 one variable is present. Okay. So now initially we have chosen two variables x and y and now we are converting the two variables into a single variable. So that is known as decoupled. Okay, coupled means pair, decoupled means single. Okay, so we got this is since we have taken two pendulums, we got two equations having single variable. So equation 5 is known as differential equation for pendulum A. This is known as differential equation for pendulum B. Okay. Okay.
Yes,
So
sir.
right.
Yes, sir.
Equation 5 and equation 6. Equation 5 and equation 6 in terms of new coordinate. Equation 5 and equation 6 in terms of new coordinate. In terms of new coordinates. In terms of new coordinates. In terms of new coordinates, q1 and q2, q1 and q2, which are known as normal coordinates, underline, which are known as normal coordinates, are decoupled, and each equation describe a simple harmonic type. Each equation describe a simple harmonic type. Okay, each equation describe a simple harmonic type. Okay.
Yes, sir.
Each okay. कौन लिखता प्रज्ञा पढ़ो.
Equation 5 and equation 6 in term of new coordinate q1 and q2 which are known as normal coordinate are decoupled and each equation describe a simple harmonic type.
Okay. So that means we got equation 5, equation 6 are decoupled. Decoupled means consist of single variable and equation 5 is a simple harmonic type. Equation 6 is also a simple harmonic type. Why? We know the differential equation of simple harmonic is d square x by dt square plus omega square into x is equal to 0. Okay. So it is a, if both the bobs will oscillate, then that is a simple harmonic type. Okay. So now the next question, now I am going to discuss three important things, not three, four important things, which are very, very important for short question point of view. Okay. So you write normal coordinate. The Q1 and Q2 are Q1 and Q2. So question will ask, define normal coordinates. Who can define? Who can define what is normal coordinates? What is normal coordinates? अरे कहो ना, Q1 and Q2.
Yes, sir.
Yes, sir.
Okay. So how we have taken Q1 is equal to X plus Y.
X
You
plus
can write
Y.
the answer. And Q2 is equal to X minus Y.
X
It is your
minus Y.
answer. Question will be asked, define normal coordinate. We can write, right. The coordinates which are linear combination of the coordinates which are linear combination of original coordinates X and Y. The coordinates which are linear combination of the coordinates which are linear combination of original coordinates X and Y are called normal coordinates. That means Q1 is equal to X plus Y and Q2 is equal to X minus Y. Q1 is equal to X plus Y and Q2 is equal to X minus Y. Okay, Aditya,
Yes, sir.
read the statement.
The coordinates which are linear combination of original coordinates x and y are called normal coordinates.
Okay, after that, that means, लिखलन किस एटा? That means
Q1
Q1
is equal to X plus Y. Q2 is equal to X minus Y.
X minus Y. Okay, you mark, it is important. 2 mark question. Next, normal mode of oscillation. Normal mode of oscillation. लिखला? Okay,
Yes, sir.
normal mode of oscillation. Give the heading normal. After that, you give the heading normal mode, MODE, normal mode of oscillation. You see, that means it is a type of oscillation described in terms of normal coordinates, right? The oscillation which describe in terms of the oscillation which describe the oscillation which described the oscillation which described in terms of normal coordinates in terms okay, the oscillation which described in terms of normal coordinates is called normal mode of oscillation. Is called normal mode of oscillation. Okay.
Sir.
Yes, sir.
Yes, sir.
Okay. Ruturaj, read the sentence.
The oscillation which describes in terms of normal coordinates is called normal mode of oscillation.
Okay, very good. So it is also 2 mark question. You mark important. Next, normal mode frequency. Normal mode frequency. You give the heading. Normal mode frequencies. Many times I told you, whenever angular term is not used, you identify that is linear frequency, which is F1 and F2. Normal mode frequencies F1 and F2. Okay, so right. It is defined as F1 is equal to omega. We know F is equal to omega by 2 pi. So here, since we have two pendulums, two coordinate Q1 and Q2, two frequency F1 and F2, two angular frequency omega 1 and omega 2. So omega 1 by 2 pi. What is the value of omega 1?
G by L.
G by L.
S. So this is 1 by 2 pi. G by L under root. We have taken omega 1 square. So 1 by 2 pi into square root of G by L. And F2 is equal to omega 2 by 2 pi. This is 1 by 2 pi. What is omega 2?
G by L.
We have taken omega 2 is G by L under root.
Omega 1
What is
Omega 1 plus 2k by m root over, sir.
S? This is square root of omega 1 square plus 2k by m. So this implies 1 by 2 pi. Omega 1 square is equal to G by L plus 2k by m under root. You have to remember. This is also important. Define normal mode frequency. हो गया सबका?
30 राइट को देखिए
1 by 2 pi G by L plus 2k by m under root. Suryamay Sahu.
Yes, sir.
Define null mode frequencies.
F1 equal to the omega 1 by 2 pi equal to 1 by 2 pi G by L रा root over.
Next.
F2 equal to 1 by F2 equal to 1 by 2 pi G by L plus 2k by m रा root over.
Okay. ए जो एटा देखि कहउछ ना निजे खाता देखि कहउछ
खातार लिखिछि
So F2 is equal to 1 by 2 pi G by L plus 2k by m under root. Okay. So next, another important short note is Q1 mode, right? Q1 mode. Q1 mode is known as in phase mode. Q1 mode is known as in phase mode. Okay. So in forced oscillation, we defined quality factor. The symbol is Q. That is Q factor, but it is Q1 mode. Okay. Look here. Q1 mode means in coupled oscillations, we have how many variables?
Two variables.
Two variable. One is Q1 and another one is your Q2. So Q1 mode means here Q2 will be 0. Right. Here the condition is Q2 is equal to 0. Q2 is equal to 0. What is the value of Q2?
X minus y.
X minus y.
This implies what is the that record? This implies x minus y is equal to 0. If x minus y is equal to 0, then x is equal to y. X is equal to y. What is the significance? X is equal to y. What is the significance? Who can say?
The displacement of first bob is equal to the displacement of second bob.
Yes, very good. So x means the displacement of the pendulum A, y be the displacement of the pendulum B. Both are equal. Okay, understood? So for Q1 mode, we have to write if the initial conditions, this implies if the initial conditions are so taken are so chosen, if the initial conditions are so chosen that x is equal to y, that means
Sir, if the initial condition,
if the initial conditions are so chosen, CHOSEN, so chosen that x is equal to y, that means both the bobs are displaced. That means both the bobs are displaced by same amount and in same direction. Then Q2 is equal to 0. Q2 is equal to 0. So the equation of motion for Q1 mode is d square Q1 by dt square plus omega 1 square into Q1 is equal to 0. Okay. So Q1 mode means only the equation having Q1 will be present. Q2 is equal to 0. Okay. Because are you there?
Yes, sir.
एक बार read करो. What is Q1 mode or in phase mode? You have to write on the bracket in phase mode. एक बार read करो.
Sir,
Because
Q2 is equal to 0. X minus
here,
y is equal to
here
sir.
Q2 is equal to 0.
Yes, sir. X minus y is equal to 0. X is equal to y. In the initial conditions are so chosen.
If listen. If करो.
Initial conditions are so chosen that x is equal to y in direction. Then Q2 is equal to 0. So the equation of motion for Q1 mode, सर उसके बाद सर नहीं लिख पाए सर.
अच्छा नहीं लिख पाया. क्यों नहीं पूछा सर? हम नहीं लिख पाया.
अभी तो लिख होने वाले ही थे सर.
हाँ तो तुम जो करेक्शन करो. इफ द इनिशियल कंडीशंस आर सो चोजन दैट x इज इक्वल टू y, दैट मीन्स का सिंबल यही है I.E. दैट मीन्स both the bobs are displaced by same amount and in same direction. Then Q2 is equal to 0. So the equation of motion for Q1, this is our rigid support. This is the string. The bob is attached here. This is the second string. Bob is attached here. And both the bobs are connected by a spring. This is a pendulum A. This is a pendulum B. So the string will be parallel manner, so that whatever the distance covered by pendulum A, that equals to pendulum B, and both are in same direction. Okay, हो गया diagram?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So you can add one sentence after the diagram. Here, the spring does not play any role. ये जो स्प्रिंग के साथ जो कनेक्शन है ना, उसका कुछ रोल नहीं होगा, इंपोर्टेंट नहीं होगा. Here the spring does not play any role and the bob will oscillate and the bob will oscillate and the bob will oscillate as if there is no coupling. As if there is no coupling. मीन्स अजीब विकास कंटिन्यू करो, क्या लिखे?
Yes, sir. Here the spring does not play any role and the bob will oscillate as if there is no coupling.
Yes. So Q1 mode में both the displacement are same. We can say the spring has no role, and the bob means the metallic bob will oscillate as if there is no coupling. Okay. Next, right. Another one is Q2 mode. This is known as out of phase mode in bracket Q2 mode in bracket out of phase mode. Q2 mode means here Q1 will be 0. Here Q1 is equal to 0. So this implies, what is the value of Q1?
X plus Y.
Sonila, X plus Y. X plus Y is equal to 0. So this implies X is equal to minus Y. X is equal to minus Y. Okay. So X is equal to minus Y. So we have to write if the initial conditions, after that you can write if the initial conditions are so chosen, if the initial conditions are so chosen that X is equal to minus Y, X is equal to minus Y, that means that means both the bobs are displaced by same amount. Both the bobs are displaced by same amount, but in opposite direction.
Sir, both the bobs are displaced?
By same amount, but in same opposite direction. Then Q1 is equal to 0. Q1 is equal to 0. So the equation of motion for Q2 mode is Soumya. Are you there, Soumya?
Yes, sir.
So what will be the equation of motion for Q2 mode?
Sir.
What is the equation of
This,
motion
sir,
for
this.
Q2 mode? You can say.
Sir, d square q2 by dt square plus omega 2 square q2 equal to 0.
Yes, very good. Okay. So Q2 mode means we have only equation having Q2 coordinate. Okay. Okay.
तो ओमेगा
Soumya, एक
1
बार
स्क्वायर सर ओमेगा 1 स्क्वायर होगा या ओमेगा 2 स्क्वायर?
अरे इक्वेशन 6 में क्या है? ओमेगा 1 है ना ओमेगा 2 है? देखो
सर ओमेगा 1
ओमेगा 1 ओमेगा 2 we have
Two, sir.
taken.
Omega 2, sir.
Sir, omega 2. Sir, omega 2.
यस 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 सर.
Yes. So Soumya, एक बार रीड करो. What is Q2 mode?
Sir, x plus y equal to 0. That implies x equal to minus y if the initial conditions.
Soumya, here Q1
Yes,
is equal to 0.
Here q1 is equal to 0. Sir, if the initial conditions are so chosen that x equal to minus y, that means both the bobs are displaced by same amount in opposite direction. So the equation of motion of Q2 mode is d square q2 by dt square plus omega 2 square q2 equal to 0.
Okay. So I think you have not mentioned, you have left the one line. You have written, as you said, if the initial conditions are so chosen that x is equal to minus y, that means both the bulbs are displaced by same amount but in opposite direction, then q1 is equal to 0. Okay, Samya, you correct the sentence. You have not
Yes, sir.
written. Then q1 is equal to 0. So the equation of motion for q2 mode is this. Okay. Now you do this diagram. So look here. X is equal to minus y means both are displaced, both the bulbs are displaced by same amount, opposite direction. If pendulum A moves along this direction, left hand side, pendulum B goes right hand side. Okay, you do this diagram. Okay.
Yes, sir.
Yes, sir.
So since what will happen? The two bulbs oscillate in opposite direction. We can say opposite phase. It is called out of phase mode of oscillation. It is called out of phase mode of oscillation. Okay. So now if you compare omega 1 and omega 2, which is greater?
Omega 2.
The 2.
Omega 2.
Yes, because omega 2 is equal to omega 1 square plus 2k by m. So you have to remember omega 2 is greater than omega 1. So in Q2 mode, the frequency of oscillation gets increased. Okay. So the two pendulums vibrate in opposite phase. Okay. Two pendulums vibrate in opposite phase. And in
Yes, sir.
coupled oscillation, the two pendulums, two bulbs are displaced. Oscillation. Okay.
Yes, sir.
Okay. So that means we have simple harmonic, damped harmonic, that is DHO, SHO, forced oscillation. After that, resonance, sharpness of the resonance. Okay. One question was asked on your first internal. Uh, the total energy. Achha, you write the question. One question. The total energy of one dimensional. All of you write. Simple harmonic oscillator is
Sir, one
0.8.
dimension.
One dimensional simple harmonic oscillator is 0.8 org. 0.8 org. What is its kinetic energy? What is its kinetic energy when it is midway between mean position and extreme position? What is its kinetic energy when it is midway between mean position and extreme position? Okay, you do now. You do this problem.
Sir, 0.4 or
0.4
4 hours.
or okay. Any other answer? Who can say? So all of you got the message regarding reopening of the college.
Yes, sir.
Yes, sir.
कब से ओपन हो रहा है?
14th February.
14
हाँ?
14 February Monday.
मंडे। अच्छा, तुम लोग कब आओगे? हाँ?
13 को
14 को
13
13। अच्छा, तुम्हारा तो हॉस्टल 10 से 13 तक शायद रीओपन है। हम्म हम्म। ओके, कितना आंसर? कुमार चिदानंदम
Sir, 0.4.
0.4। सौम्या
Sir, 0.4, sir.
मोनालिसा गौड़ा मोनालिसा always she is putting the message I was present, but there was not her name on the screenshot. Monalisa, are you there? Okay. So Soumya, tell me how you have done. Soumya, बताओ ना कैसा? चिदानंदम समय सुनी କହିଦେଲା ନାଇଁ?
Sir, kinetic energy ର formula sir ଏମିତି କହିଲି 1/2 omega square a square minus x square. ଏଠି total energy ଟା ଦେଇଛି 0.8. କିନ୍ତୁ mean position ଆଉ extreme ରେ ପଚାରିଛି। ତ sir ଏମିତି calculate କରିକି କରିଛି 0.
अच्छा, सुनो आंसर भूल। क्वेश्चन पढ़ चिदानंदम।
Sir, this is the total energy of one-dimensional simple harmonic oscillator is 0.8 org.
Okay, take a break. So total energy is given. Total energy means E is equal to 0.8 org. The unit of energy is org. Okay.
Yes.
Next.
And then what is its kinetic energy when it is made up?
Okay. What is its kinetic energy? So kinetic energy symbol I have taken EK. We have to
When it is made away its mean position and extreme position.
midway. Okay.
Sir, midway.
This is the mean position. Mean position means the rest position, the origin. Okay, where the body will take rest. So this O is known as MP. MP means mean position, and this is known as extreme position. Extreme position means the position at which the body covers a maximum distance on either side of the mean position. मीन पोजीशन को राइट को कितना डिस्टेंस, लेफ्ट को कितना डिस्टेंस मूव हो रहा है, so that position is known as okay. So that position is known as extreme position. So what is the distance? So that distance is known as A, that is the amplitude. Distance covered is known as amplitude. So we have to find the kinetic energy in between mean position and extreme position. The distance is A. That means at the midway. Midway means midpoint. If the total distance is equal to A, what is the midpoint? A by 2.
A by
By
2.
Understood? So
Yes, sir.
you have to find the kinetic energy at A by 2. So this position, suppose P be the position. Okay. So P be the position where the distance is A by 2. Okay. So what is your kinetic energy formula? Kinetic energy is equal to half m
MB.
omega half m v square.
Omega
But
square
here,
into
if you put the v, this will be a square
minus x square.
minus s square. Okay. So
Yes, sir.
लेख s sir कहला बनी e के we have to determine at x is equal to a by 2. A by 2 means midpoint. कितना होगा? Half m omega square a square x जगह हम कितने पुट करी भी a by 2 रा whole square कितना होगा? a square by 4. मैं डायरेक्ट लिखी देली बुझेला?
Yes, sir.
This is the formula for kinetic energy at any position. As per the question, we have to find at x is equal to a by 2. If you put a by 2 the whole square, a square by 4. So half m omega square. So LCM is equal to 4, 4 square minus a square. कितना ही जीवो?
3
3
square
by
by
4 a square. So this implies 3 by 4 into half m omega square into a square. What is the formula for total energy? 3 by 4. This is the formula for total energy. E.
0.8.
3 by 4 into 0.8. केता अब काटले 4 काटले
0.6
0.2
ହଉଛି।
ଆଉ 0.4 କେମିତି ହଉଥିଲା 0.6 अर्ग ହେଲା ଏଇଟା ହଉଛି ଟୋଟାଲ ଏନର୍ଜି ର ଫର୍ମୁଲା ହାଫ m ओमेगा स्क्वायर a स्क्वायर ବୁଝିଲା अंडरस्टूड अरे अंडरस्टूड ना नहीं
Yes, sir.
Yes, sir.
okay so this is all about the oscillations later if time permits we have to do the other problems okay so the next topic is wave with your color pen give the heading as waves okay दे दिए कलर पेन में हेडिंग any idea about wave who can explain what is wave बताओ
It is a disturbance in a specific medium.
it is a disturbance
In the particles of a specific medium.
anybody can
Sir, it is a disturbance, sir, which travels, which travels a particular distance in a particular time.
particular way. Okay so very I shall tell you one common experience okay it is a matter of common experience that if you drop a stone into the water in a pond what will happen have you seen when one stone is dropped into the water in a pond the water ripples or waves are propagated naiki if you drop a stone what will happen the water ripples you can say ripples or the waves will be produced okay so when the stone what is the mechanism when the stone comes in contact with water okay look here just a minute this is the pond this is the water particles are in stable position am I right when the stone, suppose this is the stone, when the stone comes in contact with some of the water particles, what will happen? The particles will be disturbed. The water particles set into vibration, set into oscillation, the neighboring particles. Suppose the stone touch this particle. Okay, when the stone touch this particle, okay, this particle will be disturbed, and this particle will disturb to the next particle, and this particle will disturb to the next particle. So like this. Okay. So the water particles set into vibration the neighboring particles. So the disturbance, instead of being continued to a place, spreads out the entire pond. So don't think that the stone touch the particles here, the disturbance will be present over here. No. That disturbance will be spread into the entire pond, spreads out the entire pond. Okay, understood?
Yes, sir.
Similarly, if a piece of paper or straw is placed on the water surface, the paper or the straw will not travel, but the paper will move up and down. The paper will move up and down, indicating that water particles are also moving up and down. Okay, thus we can say during the motion of a wave, the particles of the medium execute vibratory motion about their mean position due to the property of elasticity and inertia of the medium. So, wave motion is a form of disturbance. Suppose in your class, offline class or online class, one student will get disturbed. The entire class will be disturbed. Similarly, we can say wave motion is a form of disturbance which travels through a medium. So here medium is water due to the repeated periodic motion of the particles about their mean position. Okay, and the motion being handed over from one particle to the other. Okay, so here the water particles are not selfish. Okay, if one particle will be disturbed, then that particle disturbs the neighboring particles. Okay, so it is a type of disturbance. Okay, so next class we shall continue. So now I am going to take your attendance. तुम्हारा वेब पढ़ा है प्रज्ञा?
No, sir.
Okay.
ओके 10ଟା 15 डायरेक्ट अटेंडेंस पकोजी सीएमएस रे 10ଟା 15 केता हबो एटा 11टा 15 Okay, so okay, serial number 1 Abhinandan Das. Abhinandan Das. Okay. आदित्य कुमार,
Present, sir.
आदित्य, आलोक, अमन, अमित, अर्जित, अरुण, आशीर्वाद, आशुतोष, विकास, चिन्मय,
Present, sir.
তারপরে হচ্ছে বিনায়ক, বিপ্লব, ব্রহ্মানন্দ, চিন্ময়, চিন্ময় মহান্তি, চিত্তরঞ্জন,
Yes, sir.
डब्लू, दिव्यांशु,
Yes, sir.